Hi, in this video, I want to take another view at piezoelectric effect and look at it from the point of view of a dielectric, or in other words, a capacitor. Okay, so let's take a solid, and let's say there we have a capacitor. Basically, a capacitor is two parallel plates with a dielectric in between, right? And you have a capacitor with a non-piezoelectric dielectric in between. Okay, now if you apply a stress on this capacitor, let's say, uh, let me get the pointer. So let's say we apply a force in the vertical direction. What do you expect? So you have the stress in a compressive stress in the vertical direction, and what you expect is a strain in the vertical direction. Okay, and that stress and strain are related by a constant, which is the compliance in this case. Now, at the same time, if there is a charge on the capacitor plates, then we can write the electric displacement field is related to the electric field that is produced by the charge, right? And this electric field can be written as, because this is a dielectric medium, it can be written as the electric field that relates to the free space and a polarization vector. Okay, polarization basically refers to uh, the atoms in the material aligning themselves according to the electric field and creating some kind of a flux in between. Okay, so both these, okay, let's uh, even if you want to leave the details of these equations alone, here's what I want to just convey. In any solid, in just about any solid, if you apply a stress, you get a strain. If you apply an electric field, you get a displacement current, or you get a charge distribution on the plates. Okay? So, so if you take a capacitor with a solid, those are the two phenomena you get to. One is a mechanical phenomena, another is an electrical phenomena. Okay. Now what happens in piezoelectric effect? Here's what's the difference with a piezoelectric effect. Let's take a look at the mechanical displacement. So here we have applied a stress and we've got a strain, but in addition to the strain, we also have an electric field developing across the piezoelectric sensor. Okay. Similarly, in this case, in the electrical case, you have applied an electric field, you get a displacement current, but you don't just have an electrical phenomena, but you have a stress on the plates as well. So what's happening is the electrical and the mechanical phenomena have been interlinked in the piezoelectric crystals or piezoelectric solids. Okay, and of course the stress because of the electric field is related by a constant d, and the electric field because of the stress is related by another constant, and these two constants d and d prime are equal and are equal if the surface area of the material is not changing, and they are called the piezoelectric charge coefficient. uh, this is basically the same slide again, basically uh, talking about the electric field not only generates the displacement current but generates a stress, and similarly a stress not only generates a strain but it also generates an electric field. So the idea that I want you to get is that in a normal capacitor without a piezoelectric material, you have the uh, electrical phenomenon going on if you have a charge, the electric field, and you have a mechanical phenomenon going on if you have a stress. Now, in the piezoelectric effect, both those get linked together. So, an electric field causes a stress or a strain, and a strain causes an electric field. Okay, and of course, as we have discussed previously, uh, it's not the case that an electric field in one direction will cause strain in the same direction. It could be various kinds of linkages. It could be that electric field in one direction causes strain in a perpendicular direction, and not just in a perpendicular direction. It could also, electric field in one direction could cause a torsional or a twisting stress, rotational stress in your material as well. And therefore, instead of just having one compliance figure or one permittivity, you can have permittivity compliance in different directions, right? If you apply stress in this direction, how much strain will there be in the rotational direction, and so on and so forth.